All right, let's jump right in. Today, we're going to explore a really powerful idea that is totally changing how we model the world around us. Everything from our own brains to our legal systems. It's a way of seeing connections that are kind of hidden in plain sight on a scale you probably haven't even imagined. So let's dive into this question. We're all used to thinking about connections as, a simple line between 2 points. A connects to B. Simple. But reality is, well, it's rarely that simple, right? What happens when a single connection links a dozen things all at once? Or what if the things being connected aren't even individual items, but entire systems?
Okay, so to really understand where we're heading, we've got to start with the basics. The simple graph. This is the foundation for everything else we're going to talk about. So a graph is our starting point, super fundamental. You've got your points, we call them vertices, and you've got your lines that connect them, we call those edges. Now the key thing to remember about a standard graph is that every single edge connects exactly two vertices. It's always a one-to-one pairwise relationship. And a phone call is the perfect way to picture this. You've got one person, another person, and a direct line of communication between them. That's it. It's simple, it's clean, it's a one-to-one connection. Okay, but what if we need to model something more complicated? Relationships that involve more than just two things at a time. Those one-to-one connections just aren't going to cut it. So let's level up. This right here, this is our first major leap. We're moving from an edge to a hyperedge. And a hyperedge is not just a line anymore. You got to think of it more like a container or a bubble. It's a single connection that can hold a whole group of vertices, all at the same time.
Exactly. We've just gone from a phone call to a group chat. It's not about pairs anymore. That one single connection, the chat room itself, links you, me, and a bunch of our friends together in the same exact conversation. So we've moved from a one-to-one relationship to a one-to-many relationship.
So here's the bottom line, the crucial difference. Graphs are for pairs. Hypergraphs are for groups, for multi-way relationships. And you really have to get that distinction before we take the final step, because things are about to get a whole lot more interesting.
All right, you ready? Because now we're taking the final leap. This is the final level of abstraction, and frankly, it's where things get really fascinating. We're about to model a world where we don't just connect individuals, but we connect entire groups of individuals. The big idea here is something the source material calls iterated powersets. Now, I know that sounds super complex, but just think of it like climbing a ladder. You start with individual things. Then you group those things into sets, right? Like a basketball team. But then, and this is the cool part, you can create a set of those sets, like all the teams in a league. You see? It's a model for a world that's built on nested, layered systems. Let's make this real with an example from the source material about hospital protocols. Okay, so at the very bottom level, you have individual vital signs, heart rate, blood pressure, things like that. Then you go up a level. A hospital might group these signals into monitoring sets, like an emergency set or a routine checkup set. Then you go up another level. Hospitals can create portfolios, which are basically groups of these monitoring sets. A SuperHyperGraph is what lets you model a connection between these entire hospital portfolios. It's a connection between sets of vital signs. So let's just quickly summarize our journey here. Graphs use edges to connect pairs of points. Easy enough. Hypergraphs use hyperedges to connect groups of points. And superhypergraphs, they use what we call superedges to connect groups of points. It's just this really logical, beautiful progression into higher and higher orders of complexity. So you might be thinking, okay, that's a cool mathematical trick, but why does it actually matter? Well, here's the thing. It turns out this one powerful idea is, well, it's astonishingly universal. It's like finding a language that can describe the structure of all these wildly different systems. According to the research this explainer is based on, a superhypergraph can faithfully represent at least 23 other distinct mathematical and real-world structures. Now, that's not just a small improvement. We are talking about a massive leap in unification. It's a huge deal. And the range of applications is it's staggering. I mean, look at this. This one single model can be used to describe everything from the structure of really complex molecules to the functional networks firing inside our brains. It applies to AI learning systems and even the incredibly intricate web of legal precedents that forms our entire justice system. And this quote from the research really just nails it. This is the key takeaway. A superhypergraph lets us see and analyze systems not just as these flat networks of simple connections, but as the deeply layered, interconnected hierarchies that they truly are. It gives us a language to talk about overlapping contexts and patterns at different scales in a really precise mathematical way. So the next time you think about a connection, whether it's in your social circle, at your company, or just how information flows online, ask yourself, is it just a simple line? Is it a group? Or is it part of a much grander hidden structure that you're only just now beginning to see?